Hi, this is Hannah Sieber, and today we're going to learn about quadratics with double angles using a calculator. So if we look at A on problem 1, if we're going to look at a problem that is like this one, we want to first know what 2 theta means. So our first problem is 3 cosine 2 theta equals negative 7 cosine theta. So if we remember, cosine of 2 theta can be replaced with 3 different equations. These equations are 1 minus 2 sine squared theta, 2 cosine squared theta minus 1, and cosine squared theta minus sine squared theta. So looking back at this problem, we want to make sure we plug in the right equation for cosine 2 theta, so that's easiest to factor out. So in this case, I'd want to plug in 2 cosine squared theta minus 1. So the rewritten equation will look like this. Now we can distribute the 3, move everything over to the left side, and then we'll factor. So this equation ends up factoring to 3 cosine theta minus 1 times 2 cosine theta plus 3. So now we're going to solve for cosine theta, just as we would in a regular quadratic. So this gives us cosine theta equals 1/3 and cosine theta equals negative 3 over 2. But since our values have to be between 1 and negative 1, we can cross out negative 3 over 2 because that is not a possible solution. So our only value for cosine theta is 1/3. So since this isn't a special triangle, or isn't a special angle rather, we're going to have to use our calculator to solve it. So let's use first a unit circle to draw our double angle, and then we'll go to our calculator. So here's our unit circle, and since cosine is positive, our values are going to be in the first and fourth quadrant. So now we'll plug in the inverse cosine of 1/3 to get our answer. So when we plug it into our calculator, we end up getting 1.231. So since one of our answers is in the first quadrant of the unit circle, this is going to be our first answer. Since our second value is in the fourth quadrant, we could either take 2 pi n and subtract this value, or we could, since there's no domain restriction, we could just make it minus 1.231 for the value of the fourth quadrant. So here's what plugging in the value for the fourth quadrant would look like. We have 2 pi minus 1.231, which is going to give us 5.052. So here are the answers we get when we solve for the cosine of theta 1/3. But there is a simpler way to write this. Since we have a double angle and cosine is positive, and we have our quadrants in the first and fourth, we could actually just write the answer as plus or minus 1.231 plus 2 pi n, since this will represent both portions of the unit circle that we're solving for. So the simplest way to write it would be plus or minus 1.231, and then we add the 2 pi n because there's no domain restriction in this particular problem. So either one of these two answers are correct. Okay, so let's look at problem B now. So we have 2 cosine 2 theta equals sine of, in parentheses, theta plus pi minus 1. So the first thing I want to notice about this problem is that we're going to have to use the rap song that we've learned. So we want to do that first, and then we'll figure out what we're going to substitute for 2 theta. So the fully rap song on the right side of our equation is going to look like sine theta cosine pi plus cosine theta sine pi minus 1. So if we draw our unit circle for reference and look at where pi is located, we notice that the cosine of pi is negative 1 and the sine of pi is 0. So let's rewrite this in our equation. So once we simplify this, we end up on the right side getting negative sine theta minus 1. Since cosine theta times sine pi ends up being 0, and sine theta times -1 ends up giving us negative sine theta. So now that we have the right side simplified, we can figure out what we want to plug in for cosine of 2 theta. So since we have negative sine on the right, and we don't want to introduce another variable, we're going to want to plug in 1 minus 2 sine squared theta. So now our equation looks like this. And again, we're going to distribute the 2 on the left side, and then we're going to move everything over to one side of the equation, and then we'll factor. So after distributing on the left side, we have 2 minus 4 sine squared theta equals negative sine theta minus 1. And now I'm going to move everything over to the right side of my equation so that I have all pieces combined, and I have a positive sine squared theta. You could move it all over to the left. I just like moving it over to the right better because I like making these highest term positive. So once we've done that, we end up with 4 sine squared theta minus sine theta minus 3 equals 0. So now we're just going to factor it like we would a normal quadratic again. So this factors to 4 sine theta plus 3 times sine theta minus 1 equals 0. So now let's solve for sine. So when we solve for sine of theta, we end up with negative 3/4 and sine theta equals 1. So let's look at sine theta equals 1 because that's more familiar for us. So sine theta equals 1 is easy because it is a special angle. So drawing a unit circle for reference, we know that sine of 1 is straight up, which we know is pi over 2. And again, there was no given domain restriction, so we're going to add a plus 2 pi n to show that this repeats. So now let's look at sine theta equals negative 3/4. Again, we're going to draw a unit circle for reference. So sine is negative in quadrants 3 and 4. And now we're going to go plug in the inverse sine of negative 3/4 into our calculator. So when we plug that in, we end up getting negative 0.848. But we can't leave this as one of our answers because our answers are in the third and fourth quadrants. So I'm going to multiply this by -1 to get a positive number. And then we're going to add that to pi to get our first answer in the third quadrant. So this is going to give us 3.990, rounding to the third decimal. So what we're doing here is we're taking pi right here, and we're adding on the distance that is the inverse sine of negative 3/4 to get our answer. For the other side, for quadrant 4, we're taking 2 pi, and we're going to subtract this angle to get our angle right here. So our angle in quadrant 4 is going to look like 5.435 plus 2 pi n after we subtract the 0.848 from 2 pi. But since there's no domain restriction in this problem, we could actually just leave that fourth quadrant value as negative 0.848 if we want to. So these are your three answers. You have pi over 2 plus 2 pi n. You have 3.990 plus 2 pi n and 5.435 plus 2 pi n. Or you could have 3.990 plus 2 pi n and negative 0.848 plus 2 pi n, depending on how you want to write the fourth quadrant value of sine theta equals negative 3/4. Moving on to C. C is really similar to B, except this time we have a domain restriction. But we're still going to start the same way, and we're going to wrap along the right side of our problem. So the right side is going to look like cosine 2 pi times cosine theta minus, since you use the cosopposite sign, sine 2 pi times sine theta plus 1. So since the sine of 2 pi is 0, that cancels off the sine of 2 pi times sine theta, and the cosine of 2 pi is 1. We're left with cosine theta plus 1 on the right side of our problem. So now let's look at the left side. So we have cosine on the right. We don't want to introduce the sine to the equation. So we're going to plug in for 2 theta, cosine of 2 cosine squared minus 1. So we replace cosine 2 theta so that we get 2 cosine squared minus 1 plus cosine squared theta equals cosine theta plus 1. And we're going to combine all like terms and move everything over to the left side of our equation and factor. So then once we've moved everything over and combined everything, we get 3 cosine squared theta minus cosine theta minus 2 equals 0. This conveniently factors to 3 cosine theta plus 2 times cosine theta minus 1. Let's solve for cosine theta. So we end up with cosine theta equals negative 2/3 and cosine theta equals 1. So looking at cosine theta equals 1, because it's the easier one, we can mark it on our unit circle as being in the position of 0 into pi. But wait, in this problem, we have a domain restriction. And our domain restriction is 0 is less than theta, which is less than 2 pi. So this cannot be our answer since it excludes both the values that the cosine theta equals 1 gives us. So our answers would have been 0 and 2 pi, but we're going to cross these out because of the domain restriction. Okay, so let's look at cosine theta equals negative 2/3. So cosine is negative in quadrants 2 and 3 on our unit circle. So now let's go to our calculator and plug in the inverse cosine of negative 2 over 3. So plugging in the inverse cosine, we end up with 2.301, rounded to the third decimal place. So since we're looking for values in these second and third quadrants, we're going to have to plug in pi minus 2.301 in our calculator to get the second quadrant value, and pi plus 2.301 to get the third quadrant value. So our two answers are going to be 0.841 and 5.442. So these will be our two final answers, and they do not repeat, so we do not add the 2 pi n. So D is very similar to the other problems I've already demoed, so I'm just going to put the work up here, and you can check it. You can pause the video here. It's going to be basically the same process as problem B, and there is no domain restriction on this problem. Problems A and B on the back for 2 are also very similar to the ones I've already demoed. A gives us a domain restriction, and we're going to wrap song using cosine. Factoring, finding our double angle, crossing off the 2 because, or the cosine theta 2, because it doesn't fit within our limits of -1 and 1. And then solving for cosine theta equals -3 over 4 to get our two answers. And pausing the video one last time, here's the work for B on the back side. Similar process. Still using the rap song, plugging in for cosine 2 theta, factoring, and then using our unit circles to solve for cosine theta. And in this problem, we have no domain restriction and two different sets of double angles. And that is all. I hope that my demo was helpful, and hopefully you'll be able to get a 5 on that SIG test problem.